Hi students, in this video we are going to solve problems related to addition theorem. Now we will solve this problem. A card is drawn at random from a pack of 52 cards. Find the probability that the card drawn is a king or a heart or a red. When we have this R symbol, it can be written as, in case the event of choosing a king is denoted as A, and then event of choosing a heart card is denoted as B, and the event of choosing a red card is denoted as C, means now this expression can be written as probability of A or union. For the word R we use the symbol union. A heart, it's denoted as B, and a red card is denoted as C. So now in this problem we need to find out probability of A union B union C. Already we learnt the formula that probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C, otherwise C intersection A, plus probability of A intersection B intersection C. We already learnt this formula, so we are going to apply it. We know that probability of choosing a king is 4 divided by 52, because there are 4 king cards out of this 52. So 4 cards are favorable to us divided by total number of cards available, 52. And a heart, there are 13 cards which has heart symbol, hence there are 13 cards which are favorable to us. So total number of possible output is 13 divided by the total number of all possible outcome is 52. Similarly, red card, there are 26 black cards and 26 red cards. Here we are choosing a red card, so 26 cards are favorable to us divided by total number of all possible card is 52. And then a king and the heart. In heart series we must choose a king and it must be heart, so the card chosen must be king and at the same time it must be heart. There is only one king card available in this with the symbol heart, so favorable number of card is 1 divided by total number of cards available is 52. And then king and red card, there are 26 red cards in which there are only 2 king cards, hence the total number of favorable king red card is 2 divided by total number of all possible outcome is 52. A heart and the red card, there are 26 red cards in which there are 13 heart cards, hence we need a heart and at the same time a red card, hence it is favorable is 13 divided by 52, and then plus a king and a heart and the red card. There are 26 red cards in which 13 cards are heart, so heart and red card is 13. Out of this 13 we have only one king, hence all the 3, a king and heart and red card, means there are only 1 divided by 52. When we simplify this we get the answer of 7 by 13. Please students always use Bodmar's rule to solve this problem. Okay, and I want to explain the same problem in a different way, because if you understand this, it will be very helpful in the future problems. When you are asked some tough questions, you will be in the position to find out the solution for it. We know that a king, the first one is probability of king. There are 4 king cards available in total in 52 cards. Out of those 4 cards we need to choose one, so which is written as 4C1, right? And this is total number of 4C1 and the total is 52C1, so answer is 4C1 is 4, 52C1 is 52. That is what is written here as 4 divided by 52. A heart, next one is probability of choosing a heart. We know that there are 13 heart cards out of which we need to choose only one because a heart is there, so we have to choose only one. This is a total number of favorable to us, and then there are 52 cards in which we are choosing one. So out of 13 we are choosing one. This is a favorable number of cards, and the total number of all possible outcome is 52C1 because we are choosing one card out of this 52. So this is total possible. 13C1 is 13, 52C1 is 52. And then red card means 26 card is there, out of which we are choosing only one. So 26C1 divided by 52C1. I hope you understand this. A king and heart, we must choose a king, and at the same time it must be heart as well. In the heart we know that there is only one card. That one card must be chosen. 1C1 divided by, out of this 52 we are choosing one in this process, so 52C1. 1C1 is 1 and 52C1 is 52. And then a king and red card. There are 26 red cards, and at the same time we must have king. It must be a king as well as red card. So a king and red card means in which we have only two cards. Out of these two cards we need to choose one, and then 52C1, sorry, we are choosing only one card which is king and red card, hence 2C1 divided by 52C1. It is marked here. Now we need to choose a heart, only one card which must be heart and red color. Heart and red color means there are only two cards because red color has two suits, so in which you can find, sorry, two suits in which we have heart means there are 13 cards, so 13C1 divided by 52C1, and there is only one card which is king, heart and red, so 1C1 divided by 52C1. If you start practicing in this way using combination technique, it will be very helpful in the tough problems. When we keep on discussing problems in this way, it will be very convenient for you. Initially you may struggle, but over the period of time you will get used to it. Now we move on to next question. The next question is, a card is drawn at random from a pack of 52 cards. It means that we are choosing only one card out of 52 cards. Find the probability that the card drawn is either jack or a queen or a king or an ace. If you observe it, if you denote the event of choosing a jack as A, and the event of choosing a queen as B, and the event of choosing a king card as C, and the event of choosing an ace card is D, ace card is D, and then if you observe it either this or that, so we have R symbol, so it can be denoted like this. Here we have four events, A union B union C union D. First we know only for up to 3 events, but we have 4 events. So first we must check for mutually whether this event is mutually exclusive or not. It is mutually exclusive, so probability of A intersection B cannot occur because jack and queen cannot occur. It must be a jack card or queen card. We cannot have jack and queen at the same time. There is no card in which we have jack and queen as the same card. In a single card we do not have jack and queen, hence it is a mutually perpendicular, hence we do not have A intersection B, B intersection C, C intersection A. Like this we do not have, all those values will be 0. Hence probability of A union B union C union D is equal to probability of A plus probability of B plus probability of C plus probability of D. Now I will explain this concept using combination technique. We need to choose a jack card, only one card out of 52. How many jack cards available means there are 4 jack cards available in 52 cards. Out of this 4 we are choosing one because which is favorable to us. We need one jack card. We have 4 jack card in which we are choosing one. So this is for total number of favorable outcomes divided by total number of all possible outcome is 52C1. We know that 4C1 is 4, 52C1 is 52. Just for your recollection, I am just writing how to find out this in case if we have 4C2, how to calculate. I am just 4C2 means 4 into 3 divided by 1 into 2. Here number 2 is there, hence in the numerator we should have only 2 numbers and it must be in the descending order of this number. And then in the denominator 2 is there means 2 into 1. In case if we have 4C3 means 4 into 3 into 2. Here we have 3, hence 3 values should be there. And then in the denominator, starting from this 3, we can write like this, 3, 2, 1. When we simplify it, we get the answer. Similarly, 4C1 means in the numerator we have only one number, in the denominator it should be 1. I hope you can understand how to calculate. And then now I move on to this probability of queen. We know that there are totally 4 queen cards in 52 cards, out of which we need to choose one queen. Hence 4C1, out of 4 queen cards we have chosen only one queen card. This gives us total favorable outcomes, whole divided by total number of all possible outcomes. There are 52 cards in which we are choosing one card, so 52C1. So here we got 4C2. Similarly, a king, we need to choose one king card. There are 4 king cards, out of which we are choosing one king card, which gives us favorable number of outcomes divided by total number of outcomes is 52C1. Similarly, an ace. There are 4 ace cards, out of which we are choosing one, and which gives us total number of possible outcomes divided by total number of all possible outcomes is 52C1. Please students, try to understand this concept using combination method. It will be very helpful in the tough problems. Next we move on to this concept. A coin is tossed 3 times. Find the probability of getting either one head or 2 heads. Either one head means one head or 2 heads. For the word or we will use union. And the next question is neither 2 heads or 3 heads. Neither 2 heads nor 3 heads. First we will represent it in the symbolic form, mathematical form. In case the event of getting one head is denoted as A and event of getting 2 heads is denoted by B means here either or is there. So we will use this A union B. I hope you understand this. A union B means P of A plus P of B plus P of A plus P of B minus P of A intersection B. So that is what we need to calculate. So P of 1 head plus P of 2 heads plus P of 1 and 2 heads. So this is the sample space available in which we need to calculate one head. We need to find out how many one head is available here. One head. So here if you observe it, this is one head in which we have one head. Here 2 heads is there, 3 heads is there. Apart from that we have nothing. We have 2 or 3 heads only. So 1, 2, 3, right? Where there are 3 outputs which is favorable to us, in which we are going to choose only one. So 3C1 divided by total number of possible outcomes is we have 8 outputs in which we have to choose only one. So 3C1 divided by 8C1, which is equal to 3 by 8. Now we need to choose probability. We need to find out probability of 2 heads. Here 2 heads is available in this 3 places. Apart from that we do not have. Out of this 3, if any one comes means it will be helpful for us. So out of these 3 outputs we need to choose only one, because only 1 divided by 8C1, which gives us total number of favorable outcome divided by total number of outcome. 3C1 divided by 8C1 is 3 by 8, and then 1 head and 2 heads, and at the same time we must have 1 head and at the same time we must have 2 heads. It is not possible. 1 head means only this available, this is available, and these 3 available, in which we need 2 head means it is not possible. That's why we are putting 0 here. We simplify it mathematically, we get the answer. I hope you understand this problem. Now we move on to this next question. Neither 2 heads nor 3 heads. In case getting the event of 2 heads is denoted as A in this problem, and getting the event of getting 3 heads is denoted as B means this has to be written as neither 2 heads. Neither means the complement of A, that is A bar. NOR, which is opposite of OR symbol, that is intersection. OR symbol means union, opposite of OR symbol means intersection. Neither nor, hence 3 heads should not come, so B bar. We need to calculate this. This expression can be rewritten using De Morgan's law as probability of A union B whole bar. Using De Morgan's theorem, we are putting the whole bar, hence we must change this or we must write the opposite sign of intersection, which is union, and we have this whole bar. It can be written as 1 minus probability of A union B. So we can use this formula. You just observe it. For neither 2 heads nor 3 heads, they are writing 1 minus probability of either 2 heads or 3 heads. Well, we already calculated, we have to find out either 2 heads or 3 heads. 2 heads is available in these 3 outcomes. Out of these 3 outcomes, we should choose one. So 3C1 divided by 8C1. 3C1 divided by 8C1 is equal to 3 by 8. This you already know. Then probability of 3 heads. 3 heads is available here only. We have only one output. This has to be chosen. So 1C1. We have only one possible, out of which this has to be chosen. So 1C1 divided by 8C1, which is equal to 1 by 8. Probability of 2 and 3 heads. We must have 2 heads and at the same time 3 heads. It is not possible. Hence we are substituting 0 here. So when you simplify it, 1 minus this expression, first you must simplify this. After that, this value has to be subtracted from 1. We will get the answer. I hope you understand this problem. With this, I am completing this video. In the next video, we will see some more problems related to this concept. Thank you, students. Thanks for your cooperation.